Department of Computer Science and Engineering. Today we are going to discuss about a design thinking based CPU scheduling. As traditional way of CPU scheduling in operating system is carried out by using FCFS and SJF in order to find out turnaround time and the waiting time. Today we are going to briefly discuss about a design thinking based CPU scheduling and how we are going to implement by means of empathizing, defining, ideate, prototype and testing in a real world with a user scenario based solution. And here are our students where we will be discussing in detail.
CPU scheduling is the method by which an operating system gets to decide which process can use the CPU first. They use algorithms such as round robin and first come first serve. Though they use these kind of algorithms, they come with time constraint. That is when the DT-based CPU scheduling comes into action.
A DT-based CPU scheduling is a technique which assigns CPU time to a task with a fixed time interval and deadline-based time. So it ensures predictability, which is guaranteed to run a task at specific time. There is actually two types: deadline-based and time slot deterministic based. So actually, a deadline-based CPU scheduling is a technique which assigns the time based on the deadline, and time slot is assigned based on the time they given. So this is actually necessary, which without this will lead to system error.
Adding to these algorithms, one of the most popular DT-based algorithm is earliest deadline first, where it selects the task based on the nearest upcoming deadline and adapts dynamically in the task to arrival at changes. And another one of the popular algorithms is rate monotonic scheduling, where it assigns the schedule based on the frequency of task repetition. The shorter the period of task, the higher priority of the task. These algorithms are widely used in embedded systems and in medical devices and automotive software where timing is crucial.
So as we all discussed about the DT-based scheduling, when it comes to the importance and the application, it actually plays a vital role in the real-time application. For example, we take a airbag deployment in a car. If it delayed for a millisecond, it will end up in a life death. Okay, so it is as similar as when it comes to the peacemaker. The timing is very important because it is the difference between the life and death. And this DT-based scheduling ensures the critical tasks are executed at the precise time, and it also helps to the task safety and make the system very integrated.
So we are going to directly implement our CPU scheduling with our DT-based system. So at first is empathize. So empathize is where we are going to analyze our problem in the CPU in real-time base. So when assigning the task with the CPU scheduling, there are two types. One is real-world time task and the background task. Based upon the priority of the task, we are going to make the workload balances. So first we need to empathize our problem, and the next is define. So define is how much fairness and how we are going to make the responsive and the fast of the application to run. So such that we need to have a very good CPU scheduling for our real-time one. And next one is ideate. So ideate is where we are going to test our where we are going to develop our model. So during the developing, we need to analyze all the aspects in which it is going to make sure no reduction or any kind of struggle should come between any task is being scheduled. And the next is prototyping. Prototyping is where we need to build our product, and then we need to analyze in each and every test cases. At last is testing. One of the major important thing the testing occurs, we need to check with multiple test cases where our system performance with the high efficiency and the performance. So this is our direct implementation of CPU scheduling with design thinking.
All these points discussed earlier, the CPU scheduling plays a vital role in the process execution of the operating system. There are several process scheduling algorithms such as first come first serve, shortest job next, round robin and priority scheduling. These algorithms should be chosen wisely in order to make the process execution efficient and faster. So thank you for this opportunity.